So let's move on to the last talk of the day. Unfortunately, as I told you before, Wael Al Awar couldn't make it due to an incident in the weekend. So he'll do the talk online from Dubai. I will move on to introduce him. Wael Al Awar founded Waiwai in 2009 as a principal architect after moving back to the Middle East from Tokyo. With interests in natural phenomena, landscape, and formless diagrams of relations, Wael has a multidisciplinary approach to design and is always looking to challenge conventional processes to push the boundaries of design. His projects layer his individual design sensibilities into architecture of natural light, time, structure, and landscape. By aligning with natural phenomena, Wael seeks to create an architecture that is more than man-made fabrication, but instead remains open to adaptation and appropriation. The spaces that emerge from his approach are site-specific provocations that encourage unexpected experiences, activities, and behaviors. Wael was the curator of the National Pavilion of UAE, the United Arab Emirates, for the last Biennale of Venice, that was in 2020 and 2021, and he won the Golden Lion for the best pavilion at the Biennale. So, Wael, can you hear me?
Yes, I hear you great. Hello, everyone.
Perfect. Thank you, Wael, for being here. I will let you now do the presentation. Thank you.
Yeah, thank you very much. Share screen. Okay, perfect. So I'll take you through the journey of the exhibition that we exhibited at the Venice Architecture Biennale for the National Pavilion of the UAE. And I'd like to start with this slide, which is a slide from the Mos Eisley Cafe in Star Wars, as it really reflects and represents my perception of what the Venice Biennale is. And, you know, it's a gathering place, I think, of people or creatures from all over the world that come together to engage in some kind of dialogue and discourse about architecture and the future of architecture in the world. So it is about this eclectic and heterogeneous conversation, and that is very important in our 21st century timeframe. The theme of the Biennale that was raised by Hashim Sarkis, the chief curator of the Biennale, was how will we live together? And this could have been addressed in many ways. We chose to address it in the relationship between man and our planet. And that is, of course, comes at a time where really the planet is at a crisis, and we all have to consolidate all our efforts in order to find a solution and help support and mitigate the problems that we are facing today in the climate crisis. And, you know, the responsibility of the architect and the building of our future cities comes into question. Today, we are a population of 7 billion people, and it is projected that we will grow to become 11 billion people by 2050. The question is, how will we build these cities in the coming 40, 50 years? The Bill and Melinda Gates Foundation issued a report in 2019 stating that we will have to build the equivalent of one New York City every month in the next 40 years in order to meet the demand of this growing population. So how are we going to build these cities becomes a major question. And we have to analyze and see the ways that we are building these cities today. And are we on the right track, and are our systems okay, or do we need to re-question and readdress our systems? We need to look at the responsibility of the construction industry and the materials used in construction on the climate crisis. And if we look at emission, it is clearly the data show that the construction industry is responsible for 40% of global emissions, not only CO2, but emissions in total. And then if we look at materials in more specific sense, the responsibility of cement alone is responsible for 8% of global CO2 emissions. And concrete is actually the second most consumed material on the planet by us humans after water, which is insane. One would think that it is probably something in the food industry, but actually it is cement. And if we compare 8% of the CO2 emissions with countries, it will come third after China and the USA in terms of scale. So you can understand the scale of the CO2 emission purely just by cement itself. For the past 100 years, we have been building with the same material in the same methods and in the same processes without much let's say changes or adaptation of new systems, just quite slight initiatives here and there, but the major industry is still driven by the same systems of the past 100 years. And then we have to question these systems and try to address where are they taking us and what have they done so far to the planet. It's important to also note that to produce 1 ton of cement, which can construct nothing, I mean, it's almost a column, let's say a column size, it emits 1 ton of CO2, which needs 1 tree 40 years to absorb that amount of CO2. So it's not only the global scale of 8% CO2 emission, but it's also the ratio of production to the emission. So to produce 1 ton and that emits 1 ton of CO2 is really a very archaic material, meaning, and if it was invented today, I don't think any governing body would approve such a material in place. Not only looking at the emissions, but we also have to look at extraction and the role of the construction industry in resource depletion. Today, if we look in detail, we are also depleting the earth and responsible for 40% of the resources that are consumed from the planet. Even in energy, still the construction industry uses 35% of global energy, and it comes from fossil fuel. Only 8% is from sustainable energy or renewable energy. So still we are in a very far place from finding a energy productive, energy efficient system, let's say. And finally, excess or waste, we also have to measure that. And if we look at a study by Dr. Philip Block at the ETH, he clearly defines or saying that the role and responsibility of the construction industry in general, let's say, is 40% of all the crises today we are facing in terms of the climate. And then we have to understand, you know, the modern architect was probably not changed, not challenged with this climate crisis. The you know, CO2 and the climate crisis is something that is quite of the 21st century, but it is important that we also understand what were the systems in the 20th century that have led us today to this point in time. And it's interesting, I like to show this slide because it shows how the modern architects have kind of agreed to standardize their dress wear. I don't know where this photo was actually taken, but what's interesting is that they all conform to wear a standardized clothing with slight variations, like Arata Isozaki wearing his bow tie slightly different. And that is probably, you know, the Kenneth Frampton's regional, you know, method of modernism. And if you look at Rem Koolhaas, he's not wearing a bow tie, again, trying to defy somehow this standardized system that's been agreed in some way. Also, interestingly, this article came up last year during my research where Jacques Herzog wrote a letter to David Chipperfield in reply to his David's letter, as he was the editor of Domus magazine at that time. And I won't go into detail of reading the answer, but it is about asking about the role and responsibility of the architects in the environmental catastrophe, as well as social inequality, as well as the degradation of this planet's resources. And his answer was, David, the answer is nothing. So you can see here the 20th century architect is not taking this role upon himself in order to address these issues that we are challenged with today. So the question becomes, what is the role and responsibility of the 21st century architect? And can we still accept to answer by saying that our role and responsibility is, and we can do nothing, and our responsibility, it is not our responsibility to address these matters as architects. Many people, at the Venice Biennale also turned back to the vernacular in order to address this climate crisis that we are facing today. And if you see, the pavilion of the Philippines went back to proposing sustainable wood construction, as well as the Nordic pavilion. It was presenting going back to the vernacular, which is sustainable wood construction, and Japan presented the concept of recycling existing buildings in a way. But we have to understand that in the UAE, the vernacular architecture was built from corals, meaning that it is impossible to go back to the vernacular. Maybe coral was okay when the population here was in a few thousands of people, but today the population of the UAE is 10 million, and it's also projected to become 20 million in the next 20 to 30 years. So there is this drive to also increase the population in the UAE. So going back to the vernacular is not a question that we or me as a practicing architect could look at in the UAE. So in order for me to find a solution as a practice, the solution to the problem that I have today in the UAE as an architect who is building, and we are constantly constructing. We build projects of approximately total of 30,000 to 40,000 square meters per year. Then we really need to think clearly and loudly of the materials we use and the responsibility of that material in face of this climate crisis. So to understand in order to try to challenge and solve that problem, we need to understand what was the problem of Portland cement. And the problem of Portland cement is actually it releases CO2. The excess release of CO2 is not in the heat only, but mainly is a chemical reaction converting limestone to lime that releases a CO2 molecule. So, and lime is the binder in cement. So it is the glue that glues the minerals together. So then I thought maybe in order to solve the problem of cement, if I can find an alternative binder other than lime to put in the cement mix, that could probably offer us a solution. So the problem is a geological or problem that we have to go and look at the earth and examine the earth and try to find an alternative to lime that could act as a binder. I came across the sabkhas, or the salt flats of the UAE, and I was immediately captivated by the cementitious crust of the UAE, of the sabkhas, which means it's an Arabic word which is found in the English dictionary, meaning salt flats. And what captivated me in the cementitious crust is that there's definitely a glue in there, a binder that is keeping all these minerals together. Then I started analyzing and trying to understand more in detail and depth what are sabkhas and what are salt flats, how are they formed, and what are the mineral compositions of these cementitious crusts. The geography of the UAE, 5% of it is actually made from sabkhas or salt flats, which is a huge area. And it is unlike the stereotypical image of, only desert and sand dunes, but a lot of the in between are salt flats that actually change, sometimes are flooded with water and sometimes are dried and become dried salt lakes. But these are actually living environments that are constantly moving and reacting to the climate and the weather conditions around them. And sabkhas or salt flats are not a local phenomena of the UAE, but a global phenomena. So of course there are salt flats. This is a photo of salt flat in Ethiopia, as well as the Mojave Desert in California. And Bolivia has one of the largest salt flats in the world. And I must say, actually, the UAE salt flat is the largest, most intact salt flat in the world, and is actually it contains algae in it, and it absorbs CO2. So, and then you look at salt flats also existing in Tunisia, and here we came to start to understand that actually in history, vernacular architecture was built from salt flats, and you can see that in a lot of the North African countries. For example, in Tunisia, and this is a photo from on the left from Siwa, which is in Egypt on the border of Libya, and you can see how the workers are actually breaking the bricks, extracting them from the salt flats themselves in order to use them in construction. And this city in this city, Siwa, has been standing for 800 years in the desert. It's also interesting to note that in Star Wars, this is not a stage set, but actually this was vernacular architecture that was built from salt flats. And it's interesting to see why, and to question why the image of the future or the past is related somehow to this mysterious geography or a landscape in a way. Having said that, salt flats are carbon sinks, or meaning that they absorb CO2, and actually one square meter of salt flat in the UAE absorbs more CO2 than 1 square meter of rainforest, meaning that they really are assets to the country. And they have been tentatively listed on UNESCO's list of World Heritage sites. And we need to fight for their preservation and conservation, and definitely we are not promoting their extraction in order to be used in the construction. But what was interesting to us is trying to understand what is the mineral or the glue that is working within this cementitious crust, and could that be used in the cement mix instead of lime? It's then, after extensive research here, I'm keeping it brief because we have a limited time frame for the presentation. But after extensive research, we found that the UAE is actually the third largest desalinator in the world. And actually it's after Saudi Arabia is the first largest desalinator, and USA is the second largest desalinator. And that we could actually use the desalination, the reject brine of desalination product as a byproduct, as material, in order to try to research sabkhas, because they are actually very similar environments. The sabkhas are caused by are made from the, let's say, the evaporation of underground water, and that is actually connected to the sea. And in this case, the reject brine of desalination contains the same minerals that you would find directly in sabkhas. And it's important to also understand that the UAE produces the equivalent of 4,800 Olympic-sized pools daily. reject brine that currently is being thrown back into the Arabian Sea and causing environmental disaster in the sea. As you know, salt plus water equals battery, so it is actually trapping the heat from the very strong sun in the Gulf, and then it's increasing the temperature not only in the water but the temperature also in the climate around. And already the marine life in the Arabian Sea has been almost completely changed in the past years, and constantly struggling to continue to exist with the increasing of the salinity and the rising of the temperature in the water. So we started first by trying to understand and learn what are these minerals in Sabkhaz and in the reject brine of desalination water in biochemistry laboratories. So the first collaboration we did is with the American University of Sharjah, where we analyzed in detail the different minerals or the different salts within the Sabkhaz, and as well as the reject brine of desalination water, and trying to see how could these salts be used in producing architecture. The first experiments were actually very simple experiments that we did in our office, where we actually just simply submerged fabrics, so that material that works in tension, into the reject brine of desalination water, and allowed it to crystallize over 2 to 3 days. And then once it crystallizes, something that works in tension starts to work in compression and could become a structure by itself. But the problem with these structures is that when we are using them in this method is that they are soluble, or they are temporary structures. They're not permanent structures. And they really can absorb a lot, they really do absorb a lot of humidity and react to the temperatures. So they don't offer us like permanent solutions to constructing with them, but they could be used for emergency shelters or structures that are required for temporary purposes. So, but the research, we didn't want to stop the research there, and thought this, we really need to look at it in more depth and detail to try to understand if there are salts in there that are insoluble and could be used instead of lime as a binder in the cement mix. In parallel, we were also studying the different finishes that could be produced by all these different salts, because architecture is not only about structure, but it's about wall finishes, floor finishes, etc., and trying to see what other materials can come out from these salts that we were extracting that could be used in different applications and formats, also as finishes themselves. These studies, we did them in Dubai, and we had a warehouse which we called Wetland Laboratory, where we were constantly conducting different studies at the same time through our collaborations with the biochemistry lab in the university at AUS. We also, studied the methods of also casting bigger blocks or slabs by mixing these salts with sand, and then again pouring them into a sand mold, and then removing the sand, and they could become structures. And actually they are beautiful in a sense that they are constantly in dialogue with the environment, and they are crystallizing and growing and changing, etc. It was very beautiful to see such architecture being produced, but it was not enough for us to stop at that point. And at that time, we realized, or we learned, that the NYU Abu Dhabi was also conducting research in producing cement blocks from magnesium oxide that could be sourced also from the reject brine of desalination water. So we immediately approached the Amber Lab, the Advanced Material Building Research Laboratory at New York University in Abu Dhabi, and started this collaboration in really trying to see what could we produce as insoluble structures from an insoluble salt, which is magnesium oxide. And the studies currently are in progress and still being developed. And actually, Venice was a pit stop within this broader research that we are still running and will continue to run for many years, I think, is that magnesium oxide is a salt that is insoluble when it is mixed with with sand and water, etc. So it could offer a potential to replace lime as a binder. And these are the first blocks that we produced with New York University in Abu Dhabi. And what's interesting is that the first blocks that we produced, I will show you a video here, the first blocks that we produced were extremely brittle, and they would, once you throw them down, they would immediately collapse. So the compression tests were terrible. And then we, after extensive research, learned that when carbonated or exposed to CO2, this material absorbs 18% of its mass in CO2, can become as strong as Portland cement and perform to the same compression tests. Here you can see in the video, so the piece that completely shatters is uncarbonated, same material as the one on the other side that stays intact. The other one is simply put in a room and exposed to CO2. And CO2 can be brought, we in Venice had to work with a very limited time frame and had to produce this prototype very quickly. But actually, we did similar studies in our laboratory in Dubai, also in Tokyo later. We did a collaboration with them also, Tokyo University. And the CO2 could be diverted from a smokestack of any nearby factory, or as simple as even taking it from the exhaust of a car to the material itself. And this material needs to stay for 72 hours in a carbon chamber, and then it becomes carbonated and can perform to the structural strength of Portland cement. The third collaboration we did was for the prototype to be exhibited in Venice itself. So having, having come up, let's say, with some kind of material, how do we present that in Venice? And that was the second challenge that we had. And so we decided to do a collaboration with the University of Tokyo, two laboratories, which is Sato-san's laboratory, a structure engineering lab, and Obuchi-san's laboratory, which is a lab specialized in digital fabrication and technology that supports the production of architecture and space. So we decided to present in Venice a structure that is the antithesis of modern architecture. Well, what does that mean? It means that it is a structure that has no drawing, but is actually built through communications and through a manual that is put together from different research and prototypes that had been studied previously. So the prototype is an ode in form to the vernacular architecture of the UAE, which is built from corals. So we decided to tell the builders to, imagine coral shapes, draw them by hand into the sand, molds, and then we would pour the cement into that mold, and then you would have this module. And the reason for that is, again, trying to question, where has craft gone in the 20th century in terms of producing architecture and space? What is the identity of architecture in the 20th century, and how can it be re-questioned in the 21st century? Kind of trying to readdress the systems that we have in place and trying to find new alternative systems moving forward. And that was the main, let's say, point of this prototype that was built. So these modules were all done in Tokyo University. So we did actually 2 prototypes before going to Venice. One was done in Dubai in our wetland laboratory, and one was done in Tokyo University in parallel with the students. All of these have been built with students. Again, we believe vocational learning is important, and the communication or cross-communication of different cultures talking to one another and universities is the way forward in producing also architecture and space. And this is a photo of the prototype that was built in Tokyo. I'll talk a little bit more about the technology behind assembling such a complex form, because it really needs to also be structurally calculated. And you can see in the image here the sensors that are actually placed on the top corners of the scaffolding, as well as the scanning device that the student is holding in his hand as he is building. I'll talk about that soon in other slides. And this is actually the prototype that was built in Dubai. And what's interesting is that all these forms are different because students perceive, every person, not student, but perceives or sees corals differently. Sorry, so the way they draw the corals by hand into the sand molds would really change by how you see or feel what a coral is. Also, the scale of it changes based on your understanding of scale of modules or dimensions. And Tokyo had very small modules, while Dubai had larger modules. And finally, in Venice, they had the module size that was in between both. And as I said, this needs to be structurally calculated, as it is a public structure that is attended daily by thousands of visitors, and the Biennale needs a calculation. So how do you do that? And this was, essential in the process of assembling this prototype. So here I come to Venice. I'll start a bit with the Venice and explaining what we presented and how we built it in Venice. And we presented the exhibition under the title of Wetland, in Arabic, Ardun Ladina. And why wetland? Because we actually wanted to connect UAE to Venice also, because Venice is a wetland, and the satkhas, or the salt flats, are under the category of wetland in the Global Convention of Ramsar. That is a global body that actually protects and preserves wetlands, and has, I think, 93 nations that are enlisted within it. So, and it breaks the stereotype image that we have of one another in a way, where the GCC or the UAE is seen as just a desert scape of sand, but in reality, there's a lot of these very rich salt flats that absorb CO2 within the geography and landscape that we really need to understand and build a keen interest in trying to learn more about them. The concept behind the exhibition was about tension, and the reason for that is that it is really the tension I felt on site walking in salt flats. This is a salt flat in the UAE, where you see here it's completely filled with water as the water level rises when the temperatures drop. It's only when in peak summer, when the temperatures increase, is that the water evaporates and you have this clear cementitious crust on the surface, while in the winter the water table level rises again and there's not much evaporation, so they become beautiful pools of minerals, salt minerals that are like spas. But where does the tension come from is that the fight you can see above here the cables, the infrastructure cables, and it's this constant struggle between, you know, urban development and urbanization and building and the landscape that we have, and competing with one another on existence in some way. And we wanted to show that tension in Venice, especially, you know, us as humans going from, you know, as we are expanding as a population and growing, you know, how is this tension going to be resolved between us and the planet? It's really something that is at the top of everyone's agenda, should be in addressing today. And we collaborated with the Emirati artist called Farah Al-Qasimi, based in New York, and she took these fantastic photos or images of sabkhas in Al-Ruwais in the UAE, capturing the tension you see here, the infrastructure, the power cables, and the plants, the desalination and oil refinery plants in the background, struggling to compete with one another over geography and territory. And we exhibited these as large format photos also within the pavilion at Venice Biennale. And finally, we built a prototype that is made from 2,400 modules that are all drawn by hand, and was done locally, fully in Venice. So none of these modules were done in UAE or any other place and shipped. They were all done using local sand from Venice and local materials from Venice. And the MgO, that salt that is typically that we would, you know, extract from the reject brine of desalination water, we procured the same mineral from the local market in order to produce the prototype, and not needing to, you know, ship materials in order to build the pavilion or exhibit in Venice. So these were all assembled also on site using a contractor. We wanted to build it actually with the students from Venice University, but it was not allowed by the Biennale. Again, it is a public structure and needs to be, and a contractor needs to be held liable and accountable towards the structure they built. So we were able to participate slightly with them in the building process, but they had to build it with their labor and workers. But it was interesting, as these, you know, these typical workers had never seen or imagined building something of that form, and they were very excited and keen in trying to participate in this new process or format of constructing. And here I'll show you a video where you can see, come on, he's from waiwai also. He's wearing a wrist device that lights up in blue actually when he is within the model form of the prototype. The drawings produced is only one drawing which shows the outline of actually the prototype, because we need to control the form and the number of modules within the form, as we only had a limited amount or number of modules to work with. So when it lights up blue, it means that he is within the model space, and it guides him in that territory to insert modules. You can see here on it is lighting blue. And if he is outside the model space, outside the building area, it will just turn off. So it will stop guiding him within the space of construction. Here, you can actually, Baku is building from Tosetto factory. And what I'd like to show you actually in this video is the computer that is constantly being connected with a live model being built of the structure, in order for the structure engineers at Tokyo University to be able to calculate structure during the process of construction at the same time. So there's scanning equipment, you will see it now. suspended in the ceiling that are constantly reading the stacking of the modules. You see the sensors here. And then building an as-built model as the builders go ahead. But there is no drawing or there is no format to which module gets placed where. It is really up to the builders to decide that. And then at a certain stage, we build 0.5 meter, we stop, and then they verify the structure that's as scanned. And if there is any weak point, it will show a red point on the model on the computer, and then we will have to go back to just reinforce that area within the prototype. So that's an image of the what we presented in Venice, and you can see the large format photos again showing the tension between the infrastructure and the landscape itself, as well as presenting some material finishes that we also were able to produce from different salt minerals, not only as structure, but could be as a finish. Even the prototype itself, we applied to it a salt finish that was constantly changing and crystallizing with the movement, with the sun, actually. Sorry, with the humidity, and it was constantly moving with the environment. So it was not a static object, but actually something that is constantly in dialogue with the environment of Venice. Basically, this is a brief presentation of the pavilion itself, and we were blessed to convince with the presentation to win the Golden Lion at Venice, and currently we are still ongoing with the research. But I'd also like to present very quickly and briefly another initiative that I did during the Venice Biennale with the Curators Collective as a collaboration. And the Curators Collective was a coalition of 49 countries that curators from these 49 countries decided to come together and start to talk. And it was initiated by South Korea in order to support one another during the COVID difficulty of the Venice Biennale. This Biennale was the first time in history that was postponed a full year, and we had an extra year to work. So in that initiative, I joined, I collaborated with other curators and pavilions in order to also address the waste issue produced in the Biennale. And we decided to launch a project called A Bench in Venice, where we logged down all the waste produced by different pavilions. Here, these are the shelves that we use in the carbon chamber, actually, to carbonate the modules that we have, as well as we had additional modules. So we also put them on the contribution list. Even Japan had a lot of material that they donated, and Canada had material, as well as Vocht Landscape, they donated material. And we did an international student competition in order to design benches, and we eventually built 3 benches that were exhibited in Venice, trying to address the issue of what do we do with all this waste that is produced by the making of all these pavilions. And integrating and bringing the students into the Venice platform was something that I thought was very interesting, and something that is actually enjoyable to do with these students. So we received actually 136 submissions from so many different countries in the world, and finally we exhibited them in the UAE pavilion also on the wall, and the 3 winning schemes were built, the 3 benches. This bench was built and placed in the UAE pavilion, which contained wood from the Japanese pavilion left over, as well as modules from the UAE pavilion and bricks from Wetland Landscape. Another bench was placed outside Spain, the Spanish pavilion, in collaboration with them, and that wood came from the Canadian pavilion, the Pavilion of Canada. And finally, a third bench was done and placed in the Japanese pavilion. And this was all done using the material, the brick material from leftover from Wetland Landscape, which were in the international exhibitions. Okay, thank you very much. This is a brief outline of my presentation, and I would enjoy any questions or anything we can discuss.
So, Wael, thank you very much for your presentation. It was really interesting. So we're going to move for some questions from the audience. So I don't know if someone here in the room wants to place a question. No? Yeah, here.
There.
Thank you very much. Thank you very much. It was a wonderful presentation. I don't want to ask something too technical, but I'm actually very curious. Wetland Lab has been trying to create this mixed environment where augmented humans with extensions, let's say, can be guided to build something that otherwise would be very complex. Like they did this with chopsticks and glue a few years ago. I didn't know about this one, which looks amazing. So I would like to understand it a bit better. So for example, these coral elements, they were stacked, but were they actually scanned before? So did the model know what the elements look like? Just the aggregation was scanned live?
Yes, yes. The aggregation was scanned live. The modules, they were not scanned beforehand. We actually divided the prototype into 7 layers horizontally. So what we would do, we built layer 1, which is about 40 centimeter height, and then we would scan these modules and put them onto the digital, using the Wetland Lab, let's say, technology. And then Sato-san's laboratory would take that model and analyze it to confirm the structural integrity of that layer. And once we get a green light of that layer, we start with layer 2, and it takes a few hours. So you build, it's again, you are changing your systems of construction, where usually an architect goes to site with a perfect set of drawings and expects the contractor to build the structure to the millimeter based on his drawings. Here, the architect goes to site with modules and an outline of the form. That's it. All we have is an outline of the form. And the reason, again, we put an outline is that we are limited in space. We have to ensure egress routes, fire exits, etc. And we have a limited number of modules to make sure that the builders, again, are guided somehow by a volume, so that they do not exceed the number of modules that we have tremendously. This is quite basic as how it was put together.
Can I follow up?
Sure.
Yes, sure.
And it's kind of like what I expected, which makes it very impressive, actually. I'm wondering, were the builders given any instructions as to the logic that these modules are put together? Because if you give a person who has never built a masonry wall a bunch of bricks and ask them to build a wall, they can actually do it wrong. So
no, of course, we have a construction manual. So we don't have drawings, but we have a procedure. So we give them a document. Maybe next time I should include a few pages of that document into the presentation. It's quite interesting. It just gives tips also on how to draw the forms, because the builders also, they draw the modules themselves. So we give them tips on the module forms, like, for example, draw modules that would interlock with one another. Preferably their legs are not shorter than 5 centimeter, 50 millimeter, etc. And then once they come to stack, we show different ways of how modules could be stacked together in order to make sure that they are kind of stable somehow. But again, I mean, it was really easy. We thought, we went early to Venice thinking this was going to take 3 weeks to build it. We built it in 5 or 6 days, and then we had almost 2 weeks of extra time, actually, and they caught up really quick. It's not that difficult. I mean, especially it's not a structure that is bearing any live load, which makes it much easier in that sense.
Perfect, thank you.
Well,
More questions?
No? Anyone? So I had, well, not a question, but maybe more an observation. I had no idea of the scale of this brine byproduct. And you told us that it's expected that the population in UAE will double in the next years. And I can imagine that this submaterial will increase even more because you know, you need drinkable water, and actually all the world will need more drinkable water because it's something that it's going away. So can you share with us if you know some more researches on how to implement this material in construction or not, or how are people looking at this? Because if it's now a problem, it will be even greater in the future.
Exactly. I mean, again, the question we were raising at Venice is that, you know, could we start looking at industrial waste as our new vernacular, you know, as cities? Again, we are not proposing that this material be used in Japan. We are proposing this material could probably be used in Chile because, again, Chile is a high desalinating country. And the world is all moving towards more and more desalination, as you rightly said, as we have a huge water problem coming up, not only in the Gulf countries, but USA is the second largest desalinator on the planet. And you know, the agriculture industry, all in California and in west of USA, is all requiring desalination at very high levels. So I presented this research actually a couple of months ago at UNESCO to 52 delegate countries that were represented by ministers and as well as ambassadors to UNESCO. And the UAE Ministry of Culture has been strongly supporting this project and this research to be taken on board by other countries also as partners. As you know, we have no interest in patenting this and trying to hoard the information. We're just encouraging everyone that produces a huge amount of reject brine to also start looking and addressing what will they do with their reject brine. As what we are doing today as throwing it back into the sea is a huge environmental disaster and cannot be expected to continue in this format.
Yeah, okay, thank you. So, any more questions in the audience? No? Yeah, there
In the middle.
This product can become
like a permanent, yeah, is the material a permanent solution, or will it eventually disappear with time? You know?
No. This material. This is what I was saying. You know, the earlier tests were kind of soluble salts that we were using, and they would dissipate. But finally, this magnesium oxide-based cement is an insoluble salt, meaning that it doesn't disintegrate. It performs exactly like Portland cement, but has different properties. I didn't go into details of these properties, but again, since it's a salt-based cement, it cannot be reinforced with steel as it will corrode the steel. So in Venice, the modules themselves, we used natural fibers from trees as elements of tension in the modules to create the tension that's necessary, rather than using wire mesh or something like that. In the UAE, we used palm fiber to reinforce these modules. So I would definitely say that we need to still study more the weathering aspect of this material, but it is so far the science shows that it is equivalent to Portland cement in performance of lifespan.
Thank you.
Perfect, thank you.
More questions?
No?
No? Check. No.
Well, so, Wael, I think we'll leave it here. Thank you very much for being with us from
Thank
Dubai
you.
and to share this amazing project. So I think it was very interesting and very new thing that we can now imagine in our project. So, Wael, thank you for your time. Thank you for being with us.
Thank you very much. It's a pleasure. Thank you. Thank you very much. Take care.
Bye.
Have a lovely evening. Thank you.